Hello, Algebrites. As a supplement to the previous video, we're going to look at example number 4. So we're going to use the inverses of functions theorem to determine whether f and g defined by f of x is equal to the square root of 2x minus 4, and g of x is equal to x squared plus 4 divided by 2 are inverses, and we're going to verify by graphing. Remember that when we embed one into the other, g of x goes into f of x, we should get x. And of course, the other should be true as well. Okay, so let's start off by taking this entire function right here and squeezing it right there. So that is going to be f of g of x when we embed g within x. So f of g of x is equal to, we do a big square. Now I'm going to need a lot of space here. So let me actually start with the fraction so I know how much space I have. Okay, then we double that, put the radical around it, and negative 4 is there. So again, what did I do? I took this function, embedded it into there. So it's 2 times the function minus 4, 2 times the function minus 4. Okay, now let's see what happens when we simplify things here. All right, so clearly we notice that the 2's reduce. So my next step there is going to give me x squared plus 4 minus 4. And notice we have the square root out there. So from here, we see that the 4's reduce because 4 minus 4 is 0, and we're left with the square root of x squared. And of course, that end result is x. So is it true that f of g of x is equal to x? And the answer is yes. So far, so good. Okay. Notice it says, again, as I reply, it says if and only if. If and only if. So we need to double check for both of these. So I'm going to substitute, now I'm going to do the inverse, or the converse maybe. Here I'm going to put this entire function embedded right there. So that would be g of f of x is equal to, so we are going to have a fraction there. So I'm going to put square root, so radical 2x minus 4. Square that, add 4, divide by 2. Again, all of this function here is squeezed into x there. Okay, so what do we do here? Let's see here. Notice that the square and the radical are inverses. So now we are left with just what is inside the radicand plus the 4, all divided by 2. And now we see here that the 4 is reduced to 0, and then we have 2x over 2. And then, of course, we see that the 2's reduce there, and we are left with x. Dun, 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 dun. So our conclusion is yes, these are inverses. They are inverses. Okay, so now let's verify this by graphing. So let's take a gander here. I'm going to graph the first one here to be the radical situation, and then graph the x squared plus 4 over 2 to get the blue, and then we graph the x equals y. This is the line of reflection. Now, I do want to point out to you that this guy right here is only half, right? So just for our purposes here, let me go ahead and place in inside here the inverse, not the inverse, the negative of that function there. So radical 2x minus 4, whoopsie, minus 4, like so. All right, so now notice we do have the complete parabola that's been rotated. Okay, and we do see that this point here reflects to that point there, this point here reflects to that point here, this point here reflects to that point there. etc. So yes, indeed, it does verify by graphing. All right, we are done with that. Your turn on practice number 4. Good luck.